Ignition sequence start.
Good morning. You're looking at Mission Control Houston, where members of the Orbit 2 Flight Control Team are now at work in the International Space Station Flight Control Room. The specialists here are monitoring the systems on the station and following along with the Expedition 63 crew members as they move through the last scheduled tasks of their work week. Commander Chris Cassidy and flight engineers Anatoly Ivanishin and Ivan Wagner will spend time exercising and cleaning house and visiting with family, as well as getting a Cygnus cargo ship ready to depart the station next week.
Welcome to Space to Ground. I'm Sandra Jones. This week, a cargo vehicle is prepared for its departure, Slime makes its space debut, and we honored our nation's educators with a downlink in celebration of Teacher Appreciation Week. NASA astronaut Chris Cassidy has been preparing the Northrop Grumman Cygnus CRS-13 cargo vehicle for its upcoming departure from the space station. CRS-13 is scheduled to be released on Monday, May 11th. Cygnus will carry thousands of pounds of trash away from station to burn up in Earth's atmosphere upon re-entry after completing a secondary free-flying mission. Live coverage of release will be shown on NASA TV and the agency's website. Nickelodeon's famous neon green slime made an appearance aboard the orbiting laboratory as part of the non-Newtonian fluids in microgravity experiment organized with the ISS U.S. National Laboratory. During their stay on station, NASA astronaut Christina Cook and European Space Agency astronaut Luca Parmitano demonstrated the differences and unpredictabilities in fluid movement in a zero-gravity environment using the iconic slime. On Wednesday, educators from across the nation had the opportunity to ask questions to NASA astronaut and current space station commander Chris Cassidy in celebration of Teacher Appreciation Week. Thank you to all of the educators worldwide for your hard work, dedication, and everything you do for our students. We appreciate you. Keep sending in your questions using the hashtag AskNASA. We'll see you next week.
Here on Earth lately, we've all learned a lot more about tracking the transmission of disease. Well, microbes live everywhere, and that's why scientists at NASA's Johnson Space Center constantly monitor the bacteria and fungi on the International Space Station. Now they're using DNA sequencing to identify the microbes in orbit without having to return samples to Earth for testing. It's an important step to keep crews and the places they visit safe on future deep space missions. The International Space Station's laboratory modules support scientific experiments in a number of different disciplines. For example, the Flame Design experiment is looking into the quantity of soot produced under different burning conditions. That could generate data that leads to the creation of new burners that are more efficient and less polluting. The International Space Station's laboratories house one-of-a-kind scientific research which takes advantage of the lack of gravity in space to test hypotheses in ways that can't be done on Earth. In the Destiny laboratory, crew members use a special piece of equipment for experiments which involve potentially hazardous materials. And in the Kibo module, the astronauts are using a newer and bigger version of that glove box to support life sciences research.
Thinking inside the box. Presented by Science at NASA. Most people picture a glove box as the small space on the passenger side of your car. But if you're an astronaut floating 250 miles up, you might picture a large glass enclosure that allows you to conduct experiments that could change how we live both on and off Earth. This is the Microgravity Science Glove Box, or MSG. It was installed in the International Space Station, or ISS, in 2002 to allow small and medium-sized investigations from many disciplines, including biotechnology, combustion science, fluid physics, fundamental physics, and materials science. Many of these experiments can involve fluids, flames, particles, and fumes that you wouldn't want to escape into the space station's enclosed space, where they might make the astronauts sick or damage the station's sensitive computers and electrical systems. Instead, crew members install investigation hardware into the box and seal it shut. Next, they insert their hands into what's known as a glove ring assembly to safely manipulate their experiments or samples. Glove ring assemblies are available in a variety of configurations to accommodate differences in crew members' hand sizes as well as preferences in tactile response. The investigator views his or her work through an acrylic window. There's even the capability to install a high-definition camera system with a real-time video link installed inside the box to allow investigators on Earth to watch experiments being performed. The MSG has proven so popular over the past 16 years that a second glove box is being added to the station. The new model will focus exclusively on life sciences investigations and is known as the Life Sciences Glove Box, or LSG. This fully enclosed facility will allow crew members to perform developmental biology experiments on cells, insects, aquatics, plants, and animals. The LSG is almost twice the size of the original MSG and can accommodate 2 astronaut crew members, sometimes guided in real time by scientists back on Earth to conduct one or more experiments simultaneously. Safety was a paramount consideration in its design. As air circulates through the workspace, activated charcoal filters continuously clean it by absorbing chemicals that may be present. In addition, a high-efficiency air filter removes particles and aerosols. This allows the facility to provide 2 levels of containment for handling biohazard level 2 and lower biological materials. So why is it necessary to have a glove box on station devoted to life sciences? J. Michael Cole, the deputy manager of the ISS Projects Office at NASA's Marshall Space Flight Center in Huntsville, Alabama, explains. First, exploration crew members will be in microgravity conditions for an extended period of time, and it's important to note how that will affect their physiology and biology. The addition of LSG will supplement the ability to conduct those types of research experiments aboard the ISS. Second, life science experiments may give us new insights into how we treat diseases here on Earth. For instance, treatments for osteoporosis have benefited from research performed in microgravity. The next time you're asked to think outside the box, you may just want to consider one of the most unique labs ever built and think inside the box instead. For more inside information about what's happening inside the ISS, visit www.nasa.gov/ISS-science. For more on science happening on, around, and beyond our planet, go to science.nasa.gov.
Along with assisting with experiments in microgravity, and the occasional robotic arm ops or walking in space, and of course the ubiquitous other duties as assigned, astronauts on the International Space Station devote some of their time to helping students who are studying science, technology, engineering, and math. In this demonstration video, astronaut Ricky Arnold shows us how the molecules that make up water behave up in space.
Welcome to the International Space Station. I'm NASA astronaut Ricky Arnold. Our view from the ISS of Earth is absolutely magnificent, but we quickly realized we really should call it Planet Ocean. We are mostly a water planet. Water occurs here in all three phases, solid, liquid, and gas. And the presence of water on other planets and moons within our own solar system has us wondering, is there life there too? Well, why is water so special? One reason is called surface tension. So what is surface tension? Let's have a look. Surface tension is a property of liquids in which molecules of one substance are more attracted to each other than to molecules of another substance. Water is unique in that it has a high surface tension compared to other liquids. This is due to its polar property. The positive hydrogen ends and the negative oxygen ends create a strong bond. As they say, opposites attract. So the hydrogen end of the water tends to stick to the oxygen end in a nearby water molecule. At water's surface, its molecules are only attracted to the water molecules below and to the sides of them, as there is only air above these molecules. So the surface molecules of a body of water are pulled down, creating a more stable, stronger environment. That is why certain animals, like the water strider, can actually walk on the surface of water. Here on the International Space Station, the microgravity environment makes it easy to show how well water uses surface tension to stick together. We even rely on surface tension to help us wash our hair, those of us that have a lot. Thanks for coming along today and learning a little bit about surface tension. Want to learn more about the unique properties of water and do your own experiments? Try out the activity related to this video at the STEMonstrations website. See you next time.
The crew members on the International Space Station like to say they're just the tip of the spear, a small part of a large effort to explore space. And in their case, they spend a lot of their time supporting scientific experiments that they did not dream up. Here's the first part of a special series that looks at some of the other people who make this program work, the scientists behind the experiments. Maestro, cue the overture.
Feeling weighed down? Feeling the constant pull to the Earth? We all are. It's gravity, and it's a part of every single thing we do, including our science. But what if we're 250 miles above Earth, aboard the International Space Station, a laboratory like no other that offers something we can't get on our home planet?
My name is Dr. Serena Anand-Chancellor, NASA astronaut. I recently flew to the International Space Station aboard Expedition 56 and 57. My relationship with microgravity is that I got to live in microgravity for 197 days when I was on orbit. So many people ask, what is microgravity? Why do you float on board the International Space Station? Gravity acts upon all objects. We're never truly in zero gravity on board the space station. But because the space station is traveling so fast around the surface of the Earth, we're actually in a constant free fall. And that's why everything and everybody appears to float on board the space station.
We are experiencing the Earth's gravity. In fact, we're actually experiencing about 90% of what you all experience on the surface of the Earth. The difference is we're just moving so fast that as we fall, we actually fall around the Earth, and that defines orbit. So microgravity means we're not, it's not the absence of mass, which of course creates gravity, but all the objects together are in the same gravitational field and all falling together. So yes, it is a lot of fun. Floating around, of course, is one of the exciting parts of being up here on board and being an astronaut, but even more importantly, it lends itself to all the amazing experiments that we can do on board that take advantage of that microgravity environment to do things that we can't do on Earth, but that can benefit life back on Earth.
The important thing is it's so different than what we have here on the ground, where everything is pulled by the Earth at what we call one force of gravity. And what that does is it allows you to see the small forces, the small processes, the small effects of what goes on in life cell development or technical processes like combustion or fluid flow. And it helps you understand things that you may not have fully understood on Earth, where you see something happening, something assembling or disassembling, or the shape of something now going into 3 dimensions. And you learn, that's really what was driving this thing on Earth that we didn't really understand.
On Earth, gravity is affecting all research we do, and sometimes that can get in the way. Studying things in different environments can give a better picture of how they work, from diseases to fires and even things that make up products like milk or shampoo.
One of the main things we perform on the ISS is science. In fact, probably 70 to 80% of our day is performing scientific experiments.
The International Space Station is a great place to do research for several perspectives. One of those is it's a big, huge satellite orbiting the Earth. So if you have an instrument that wants to look at the Earth or look out at space, we provide the power, we provide the data, the platform for it. You don't have to go do your own new satellite. The outside of the ISS is also a very extreme environment, and sometimes you learn things by exposing your hardware, your polymers or whatever, to a different environment. You'll see something happen different than what is on the Earth. But probably one of the most pervasive uses of the ISS is just the microgravity environment, the things that we do inside the ISS. To be able to do your experiment in space without gravity, which we've all lived with forever here on the ground, which we live with every day, and we don't even realize how it governs so many things that happen around us. If you take gravity away, now some of the small phenomena, some of the small processes and forces start to come out, and you can see them, and you can see the behaviors of your experiment happening differently in space and in microgravity than you would on the ground.
It takes a lot of people to make all of that microgravity science happen. 4,000 scientists, companies, and students from over 100 countries have sent more than 2,700 experiments to the orbiting laboratory. Over the past 20 years, these studies have unlocked new discoveries and even kicked off hundreds of new microgravity experiments.
We're studying the physiology of how blood flow and the fluids in our body shift as a result of microgravity.
Yesterday, I spent some time setting up a veggie experiment. We'll actually be growing Mizuna lettuce up here.
Drew and I actually have been helping start a new experiment called the Cold Atom Lab, which will create one of the coldest places in the universe right here on the space station, almost at absolute zero.
But who are these scientists? And how do they get their research to the space station? This season, we'll take you behind the scenes of the years of preparing an experiment for space. You'll see it launch off the planet and splash back down in the ocean, and hear what it's like to hand off your research to the astronauts who serve as the eyes and hands of the scientists aboard the International Space Station.
This is our first project that is going up to the station, and our first project working with anyone involved in the space program. So it's a very exciting time for us. It'll be interesting to see how all of our planning is played out when someone else has the experiment in their hands.
NASA's Artemis program will return Americans to the moon by 2024 and help get us ready to go to Mars. And knowledge of the geology of both locations will be important. Last year, the next to last man on the moon, Apollo astronaut Harrison Schmitt, and then astronaut candidate Jessica Watkins met up at the Johnson Space Center's Moon Rock Lab so the two geologists could discuss how what we learned from Apollo will inform our efforts in Artemis.
Sample of both sides. I wouldn't bet on it. Okay, I just got a chunk of that side.
They have what I consider one of the most
Can you talk about kind of what went into your sampling strategy and how you chose which samples to bring back?
The idea was to get as broad a spectrum of new samples as we possibly could, and that turned out pretty well. We did. And in fact, we sampled at least ejecta, melt, what we call melt ejecta from 3 major basins, maybe 4. We sampled fragments that almost certainly came from the deep mantle of the moon. We didn't know that at the time. That's only recently that we figured that out. And that we also then added to our broad knowledge and history of these volcanic eruptions that have occurred on the moon over time. Now when you go to the moon on the way to Mars, Jessica, that education I think you're going to get on the moon will be very relevant to Mars. But Mars, of course, does not have that micrometeorite impact environment that we have on the moon, because it has a small atmosphere, about 1/100th of that of the Earth, and that filters out the small impact. The main weathering process on the moon are these micrometeorite impacts and solar wind spallation of the surface. Solar wind's made up of high energy particles, so they actually erode the surfaces of rocks as well as change the character of the debris layer on the moon. On Mars, the dominant erosive force is wind.
Yep.
And so if you're used to studying geomorphology here on Earth that involves wind,
you're in good shape. Yeah.
you can learn a lot
right.
about what you're going to see on Mars. But all of that comes from studying the moon.
Right.
If we hadn't had the moon, we wouldn't understand this early history of the Earth or even speculate about what it might be, speculate intelligently anyway,
right.
about what it might be.
America's astronauts come to this job from a wide range of backgrounds and experiences. Test pilot, doctor, engineer, teacher. But one thing they all have in common is that they have never been to space, at least not when they start. Like you and me, they each imagined seeing the Earth from space. Turns out that quite often, the reality of that sight is just not what they expected.
I had looked at pictures on social media and pictures in NASA archives of the Earth so many times, I actually started to get worried. What if I get up there and it's just like the pictures? I mean, that's going to be weird if that's the thing where I'm like, oh, it looks just like the pictures. I'm ready to go home now. And then on the Soyuz, my launch vehicle, I launched with the Russians. And on my Soyuz, when I first got a chance to look out my little window, which is about right here, at the Earth, there's something about looking out a round window at the curvature of the Earth that makes it just more pronounced and really makes it have a huge impact. I just had this feeling like I was way up high looking down, and we were over the ocean, and the blues that I saw, it was it was ridiculous. I'd never imagined in my entire life getting to see something that beautiful. It was so foreign for the human mind to look at that, to see that total black of space, to see the Earth highlighted that way. And then I got to see a sunset. I had one piece of paper, it had a picture of my kids on it and a few of my flight data file burn times on it, but I just took a pencil and I drew like 15 curved lines, and I just wrote light blue, darker blue, pink, purple, dark purple, all the way down to the surface of the Earth at sunset, because the scale of looking at a sun refracting through the atmosphere, it blew me away, and no picture captures that. There's no high enough dynamic range of a photo to capture what the human can see. So that first look outside completely sidelined me. I had a GoPro, and I made a recording to my brother of, no matter how much it costs in the future, come do this. You have to come do this. I mean, it's amazing. Over my 6 months in space, getting to look at the Earth every single day, it shows you something different. Every day it shows you that it's alive, it's a being just like we are. We're guests on this planet, and it's our mother, it's our father, it's our starship cruising around the sun in the middle of the solar system. There was never a moment that I looked out the window and didn't immediately grab a camera to take a picture of something that our planet was doing. It always surprised you, it's always magnificent. I'm a pilot, I'm not a scientist, I'm not a psychiatrist, I'm not a poet, but certainly when you're in low Earth orbit, looking down at the Earth, it doesn't matter if you're a physicist, a school teacher, a stay-at-home parent, or maybe you just backpack for your whole life. If you look out, you're gonna have a magical experience in your own way, for certain.
If you'd like another look at the stories we featured today, check us out on YouTube and Facebook. There are the addresses right there. And look around, because there's lots of other cool stuff you can find about NASA and America's human spaceflight program. When you're out on the internet anyway, check out Houston We Have a Podcast. That's where we talk to folks about their work in all aspects of space exploration. We post new episodes every Friday. Today, Gary Jordan talks with folks from a private institute here in Houston that is working with NASA to solve the challenges to protecting the health of astronauts in space and making future deep space exploration a success. Go to nasa.gov/podcasts for this week's episode. It's where you'll also find all our previous episodes, plus the full library of all the NASA podcasts, all of which you can also listen to on Apple Podcasts, Google Podcasts, and SoundCloud. Thank you.